Now here are some cool complicated examples of how to compute derivatives involving exponents. This is a step up from a previous video in which I just explained how to derive exponents of any base. Here I want to outline some important ideas. So this first one could think that this is a complicated exponential, something difficult to derive. But if you remember that the only thing changing here is x, pi is a constant, right? Looks like it isn't because we don't have, a number written there as usual using our Indo-Arabic numerals. Our Indo-Arabic numerals are not enough to represent pi, but still pi is a fixed number, it's a constant. So that means I derive this in the same way that I would derive d dx of x squared, which would be 2x to the first, right? I derive this the same way, dy dx, or if I represent it more carefully, d dx of x to the power is pi x to the pi minus 1 power. And that's the answer we're looking for. The power rule applies to this case. Now, if we switch things up, y as pi to the x, then now we're having a more difficult situation because now the base is pi, so the base is constant, the power is changing. So this follows the rule of if d dx of b to the x, when b is positive, then this is b to the x ln b. So in that case, dy or d dx of pi to the x, that's pi to the x ln pi, whatever that is. I don't know what it is, but that's the answer. I mean, I know what it is, I just can't represent it, like I said, using our Indo-Arabic numerals. Now C, we're using y equals x squared plus 4 to the e. Same thing as before, e is like pi, it's a fixed number, it's constant. Even though I can't represent it using our numerals, e is just some fixed number. So this is, as I treat this as if it were a 3 or something, like x squared plus 4, all that cubed. So using the chain rule, right, I can do d dx of x squared plus 4 to the e⁻ power. I do the power rule first, so power comes down, function to the power minus 1, and then derivative of the function inside, which is x squared plus 4. So eventually, if you take some time, or if you find it difficult to understand this chain rule, you can do it step by step, calling this u, but I think eventually you're expected to understand and skip some of those steps. So I'll skip it for now, but if you need, you can stop and do the more careful math of calling this u, doing dy, du, du, dx. For now, I'll leave it at that. And then the second derivative we need to do is simple. So this first one is already solved, even though it looks ugly. This is just the power rule. The derivative of x squared plus 4 is just 2x. So I'll just reorder that so it looks a little nicer. 2ex x squared plus 4e minus 1. I think I'm happy with this result. So take a second to reflect on those, because I think those can be a little difficult to absorb. It's an important distinction to keep in mind.